What if you took a dive into one of the most extreme, most violent, and most dazzling objects in the entire universe? No, I'm not talking about a black hole or a supernova, but something just as spectacular, a Wolf-Rayet star. These cosmic titans are the rock stars of the galaxy, living fast, burning bright, and going out with an unbelievable bang. So, buckle up, space explorers, as we embark on a hypothetical journey into the heart of a stellar monster. What would it be like to fall into a Wolf-Rayet star? First things first, what exactly is a Wolf-Rayet star? Imagine a star so massive, so hot, and so luminous that it literally blows itself apart. These are evolved, massive stars, typically over 20 times the mass of our own sun. They're in the final stages of their lives, and they're not going gently into that good night. Instead, they're shedding their outer layers at an incredible rate, creating what's called a stellar wind. But this isn't your average solar breeze. We're talking about winds screaming through space at millions of kilometers per hour, ejecting enormous amounts of matter, sometimes the equivalent of Earth's mass in just a single year. This process peels back the star's outer hydrogen layers, exposing its super-hot, helium-fused core. The result is a brilliant, blue-glowing star surrounded by a spectacular, expanding nebula of its own cast-off material. They are, in a word, magnificent. So, let's begin our impossible journey. For this thought experiment, we'll need a magical, indestructible spaceship and a suit to match. As we approach our target, say, WR-124 in the constellation Sagitta, the first thing we'd notice is the sheer, overwhelming brilliance. Wolf-Rayet stars are incredibly luminous, shining hundreds of thousands, or even millions of times brighter than our sun. The light would be an intense, piercing blue-white, a consequence of its blistering surface temperature, which can exceed 50,000 Kelvin. That's almost 10 times hotter than the surface of the sun. Even from a vast distance, we would feel the star's power. Our ship would be bombarded by a relentless stream of high-energy particles and intense radiation. This is that ferocious stellar wind we talked about. It's so dense and powerful that it's more like a stellar hurricane. It's this wind that creates the beautiful nebulae surrounding these stars, like the stunning ring nebula around WR-124, captured so beautifully by the James Webb Space Telescope. We'd be flying through a cosmic ghost, a glowing shroud of gas and dust that was once part of the star itself. These nebulae are rich in heavy elements like carbon and oxygen, forged in the star's core and now seeded into space. This is cosmic recycling on a grand scale, the very stuff that will one day form new stars, new planets, and maybe even new life. Pushing through this turbulent wind, our ship would start to heat up dramatically, despite our magic technology. The closer we get, the more intense the environment becomes. We're now inside the nebula, surrounded by glowing tendrils of gas. The view would be unlike anything else imaginable. We'd be swimming in a kaleidoscope of colors, a celestial light show powered by the star's ferocious ultraviolet radiation ionizing the surrounding gas. It would be beautiful, but incredibly hostile. As we get even closer, the very fabric of space would feel different. The star's immense gravity would start to take hold. Remember, these are giants. A Wolf-Rayet star packs dozens of solar masses into a relatively small volume. The tidal forces would be immense, trying to stretch our spaceship like a piece of spaghetti. It's the same force that causes tides on Earth, but ramped up to an astronomical level. Our indestructible ship would be creaking and groaning under the strain. Now, we're approaching what we might call the surface, but a Wolf-Rayet star doesn't have a solid surface like a planet. Instead, it has a photosphere, a layer where the gas becomes opaque. For a Wolf-Rayet star, this surface is a chaotic, whirling inferno. Due to the powerful stellar wind, the boundary is fuzzy and indistinct. It's not a clear line, but a violent transition zone where the star's atmosphere is being blasted away into space. We're not landing on something, we're plunging into a raging sea of superheated plasma. The moment we cross that threshold, all hell breaks loose. The temperature skyrockets to tens of thousands of degrees. The pressure becomes unimaginable, millions of times greater than Earth's atmospheric pressure. Our ship, even in our fantasy scenario, would be compressed and battered by forces that defy comprehension. We are now inside the star. Visibility drops to zero. We're enveloped in a blindingly bright, incredibly dense soup of helium, carbon, nitrogen, and oxygen plasma. The star's light is so intense here that it exerts a physical pressure, known as radiation pressure. It's this pressure, pushing outwards from the core, that helps drive the powerful stellar winds and prevents the star from collapsing under its own colossal gravity. We would be simultaneously crushed by gravity pulling us in and blasted by radiation pushing us out. It's a cosmic tug-of-war on a scale that is difficult to fathom. If we could somehow continue our descent towards the core, the conditions would become even more extreme. The temperature and pressure would continue to climb to millions, then hundreds of millions of degrees. We are now in the region where nuclear fusion is happening. This is the engine room of the star. In a Wolf-Rayet star, the fusion process is far more advanced than in our Sun. While our Sun is currently fusing hydrogen into helium, a Wolf-Rayet star has already burned through most of its hydrogen. It's now fusing helium into heavier elements like carbon and oxygen in a furious, unstable process. This late-stage fusion is what makes the star's life so short and violent. It's burning through its remaining fuel at an astonishing rate. And this is the critical point. This furious burning is a prelude to the end. A Wolf-Rayet star is a ticking time bomb. Within a few 100,000 years, a mere blink of an eye in cosmic terms, it will run out of fuel. When that happens, the outward pressure from fusion will cease, and gravity will win the war. The core will collapse catastrophically in on itself, triggering one of the most powerful events in the universe, a type IB or IC supernova. In that final, cataclysmic moment, the star would detonate with the energy of billions of suns, briefly outshining its entire host galaxy. The explosion would send a shockwave ripping through space, carrying with it all those heavy elements forged in the star's heart. Depending on the mass of the remnant core, it would collapse into either a neutron star or, quite possibly, a black hole. So, falling into a Wolf-Rayet star isn't just a journey into a star. It's a journey into the past, present, and future of the cosmos. You witness the creation of the elements essential for life. You experience the most extreme physical conditions imaginable, and you arrive just in time to see the prelude to a spectacular cosmic finale. It's a violent, beautiful, and fundamentally creative process. These stellar behemoths are not just points of light in the sky. They are the universe's grand chemical factories, the sculptors of galaxies, and the ancestors of future stars and planets. Our journey, though impossible, reveals just how dynamic and incredible our universe truly is. Thank you so much for joining me on this wild ride into a Wolf-Rayet star. I hope you found it as mind-blowing as I did. If you enjoyed this cosmic adventure, don't forget to hit that like button, subscribe for more journeys into the unknown, and ring that notification bell so you never miss an episode. Let me know in the comments what other cosmic destination you'd like to explore next. Until then, keep looking up.